Hi everyone, I'm Angelina Royappa, Assistant Professor in the Department of Electronics and Communication Engineering at SAEC Engineering College. In this lecture video, today I'm going to talk about a very interesting and a current research topic, that is Introduction to MEMS. Now, this is the contents of the video which I'm going to be discussing in the upcoming slides. I'm going to start with the basics of what is MEMS, what is the difference between an integrated circuit and MEMS, why do we need miniaturization of device, what are the advantages and disadvantages of MEMS, and finally it will be concluded by the application of MEMS. So let's start. First of all, what is MEMS? So let me start with the abbreviation of MEMS. MEMS stands for Micro Electromechanical Systems. Now using this abbreviation, you can see that MEMS is actually a technique of combining electronics and mechanical components together on a single chip. The size of this MEMS device is around 1 micrometer to 1 millimeter. Now in this PPT, you can see the image that is in the bottom. If you see that, that is actually a MEMS vibration energy harvester device. Okay, it is actually used to create energy by converting mechanical energy into electricity. But you can see that this device is placed on a finger. Okay, that means the size of this device is very small. Now, in order for you to understand the size of this MEMS device, this MEMS microscopic scale will give you an understanding of how the size is actually in real life. Now, for example, you can look at the scale. If, for example, your device is 100 micrometer, now 100 micrometer is nothing but is equal to 1 strand of your hair. Now, isn't it fascinating? This device can be equal to 1 strand of your hair, the size of this device. So, the first question that comes in your mind is, can a device be fabricated to such a small microscopic level or such a minute size? The answer is yes. It can be fabricated to microscopic level by using various MEMS fabrication techniques. Some of them are like ion implantation, diffusion, thermal oxidation, etc., like photolithography, etc. But these fabrication techniques can be discussed later on. Now, coming to the difference between an integrated circuit and MEMS. Now, generally all of you know that IC is nothing but consists of thousands of electronic components fabricated on a single chip. For example, our 8051 is an IC, is a microcontroller, etc. like that. Now, the major difference between MEMS and integrated circuit is MEMS consists of both electronics and mechanical components fabricated on a single chip. Over here, mechanical components means the actuators. Actuators are nothing but moving parts. For example, motors, pumps, cantilever beam, etc. But in integrated circuit, it is fabricated only by using the electronic components. In MEMS, it consists of a 3D complex structure. IC is a 2D structure. Now, MEMS have moving parts. IC have no moving part. Now, MEMS doesn't have any basic building blocks. It is fabricated depending on the application. But in IC, if you see, transistor is the basic building block. So, this is the major difference between an IC and MEMS. Next, why do we need miniaturization of device? That is, why do we need to fabricate such a small device? So, what are the reasons for us to fabricate? One of the most important reasons is that smaller systems tends to move much quicker, or you can say much faster compared to the larger systems, because they have very less inertia of mass, that is nothing but very less weight. Another important factor is that this minute size devices encounter fewer problems in thermal distortion and vibration. Thermal distortion means compressibility or expansion of the material at high temperatures, but these problems are very less in small devices. Also, if you see, small devices are more accurate and have high precision, which can be used in applications like in medicine and in surgery. Other reasons why we need miniaturization of devices are it has very high precision and minute size, which is very desirable in fields like satellite and spacecraft engineering. Also, it is this miniaturization system is very stable when it comes to when the system is in motion. It is stable as well as it gives us high accuracy even when the system is in motion. So this makes it more suitable for telecommunication systems. So these are the major reasons why we need a device of minute size. Now, with an example, let me help you to understand it in a much better way. Now, for example, if a person has met with an accident and say a hemorrhage has happened inside his brain. Now, the doctors want to do the operation in a successful manner. But if you see, if a doctor wants to operate in a successful manner, he has to first know the pressure level inside the brain. But all what we have, the normal pressure gauges are too big and it is not possible for us to measure the pressure level inside the brain. Now the solution for such a problem is MEMS pressure sensor. Now the MEMS pressure sensor, if you see at the bottom of this right side, there is an image. On a finger, the MEMS pressure sensor is placed. So you can see how small the size of the MEMS pressure sensor is. So this MEMS pressure sensor can be placed on top of a needle and injected into the person's brain in order to measure the pressure level inside the brain. Now using the measurement of pressure level inside the brain, the doctors can successfully do the operation. So if you see, this is why we need miniaturization of devices. In places where it is not accessible to use large devices, MEMS devices can be used, and because of that, the first thing is it is less painful, and the second thing is we can accurately do the operation. So I hope you understand in a better manner that why we need to go for small devices. Now coming to some of the advantages. One is it is highly scalable in manufacturing. So because of that, the cost is less. Then MEMS sensors are having high sensitivity, and also MEMS switches and actuators can attain very high frequencies. Also MEMS devices are very low in power consumption. Also these devices can be readily integrated with microelectronics to achieve embedded mechatronic systems, for example microphones. MEMS microphones can be used. Now the major disadvantages is that it is very expensive during research and development stage. Okay, during the initial stage of research and development, it is quite expensive. Also, testing equipment to check the quality and performance can also be expensive. So these are the major disadvantages when it comes to MEMS. Now coming to the application. So the first application is in the automobile field. Okay. Now in the automobile, the major application is in the airbag system. So traditional airbag system was quite large, and because of that there was some delay for the cushion to arrive in order to protect the person from the accident. Now if you see in recent cars, in recent BMW cars, the automotive airbag sensors can be placed just inside the steering of the wheel. Okay, now because of that, when a car actually hits the object or it met with an accident, the MEMS accelerometer sensor will immediately give a signal to the electronic control unit. Now this electronic control unit will tell to deploy the airbag, that is to bring out the cushion from the steering wheel. So this is much convenient, and also this can be further used in smart cars. Now another application is MEMS endoscope. Now this is actually a very fascinating innovation. Now generally, what is the meaning of endoscope? Now endoscopy is nothing but it is actually a medical device with light attached to it. So this device is actually inserted into the human body in order to, that is through the mouth, in order to capture the images of the digestive system. Now this device is actually large and it is a quite painful procedure. Now if you see, using MEMS technology, you can see from this diagram, this endoscopy can be just fabricated in a capsule or like a tablet. That is so small, you can see that in a tablet you can just fabricate endoscopy. Now what they do is that the patient can just swallow this capsule, And inside this capsule there are tiny wireless cameras attached to it, and it can capture the digestive system of the human being. So the main purpose of this is that it is a very less painful procedure, and also it can it can access many parts of the human digestive system where the larger device was not able to go in the previous traditional manner. Now the next application is, you can see MEMS sensors are largely used in smartphone. All the upcoming smartphones are having MEMS sensor. That is, if you see gyroscope MEMS sensor, it is used for the rotation of the pictures. And then you have MEMS micromirror that is used in cameras. So we can have much accurate and more precise pixels in the camera. Then the final application is that microbot. It is used in the field of microbot. So what is first of all microbot? It is nothing but a robot that is in a very small size, minute size. The size can be around 1 micrometer to 1 millimeter or even less. Now in South Korea, they have come to get a remarkable success in a medicine field. So what they have done is that they have fabricated a microbot which can actually unclog the arteries when a person is experiencing heart attack. For example, to tell it in a much practical way, when a person is experiencing heart attack, what happens? This microbot is injected into the human body and it travels to the areas where there is blocks in the artery. So when it experiences a block, what it does is it releases a certain type of medicine. Now this medicine will actually unclog the blocks in the artery, and the person it can stop the heart attack. So this is a great and remarkable application that is being in research in South Korea. So I hope this lecture video has given you the clarity regarding what is MEMS. Thank you.